Hello and welcome to this training program of NRRDA on the use of plastic waste in the construction of bituminous roads. Now it's always a challenge for everyone on how to use limited resources to optimum limits. And nothing could be better than using your waste to make the best. Progress and development of a nation is reflected in the quality of its roads and assured all-weather connectivity to all habitations. But connecting all habitations for a country as large as India is a huge challenge. Under Prime Minister Gram Sadak Yojana, popularly known as PMGSY, the Ministry of Rural Development has been entrusted with the responsibility to connect all habitations, with a population of over 500 in plain areas and a population of over 250 in special category areas with all-weather roads. National Rural Roads Development Agency, or the NRRDA, was established by the Ministry of Rural Development to provide managerial and technical support to rural connectivity program at the national level. At the state level, State Rural Roads Development Agencies, or SRRDAs, were established to implement the program. In the last 15 years, NRRDA, with the support from SRRDAs, has connected 1,10,301 habitations, constructing 4,37,521 kilometers of all-weather roads. Today, across the country, about 100 kilometers of rural roads are constructed every day. For this achievement, credit goes to government officers, scientists, engineers, contractors, technical and non-technical staff who are relentlessly working at all levels to realize this dream of ensuring 100% rural connectivity. They are also constantly innovating to produce cost-effective and durable all-weather rural roads. In this pursuit for improving and making roads cost-effective, scientists and engineers have successfully experimented utilizing plastic waste in construction of roads in Tamil Nadu, Karnataka, and also in the Central Road Research Institute, CRRI, New Delhi.
Laboratory experiments were conducted at Central Road Research Institute to optimize the dose of plastic waste in bituminous road construction.
Subsequently, the Indian Roads Congress issued guidelines on the use of plastic waste in construction of bituminous roads called IRC Guideline. In May 2013, NRRDA decided to encourage use of non-conventional materials as well as new technologies, including use of waste plastic in the construction of newly sanctioned rural roads. This initiative mandated 10% of the total length of the proposal submitted by a state to be based on use of a technology or materials for which IRC guidelines and specifications exist, and 5% of length of the total proposal submitted to be constructed by using technology which is new and has been accredited by IRC. Our engineers and technicians have been constructing good quality bitumen roads for ages. With all its advantages, bitumen has its own limitations, particularly when faced with water. It was found in road trials that by adding 6 to 8% of shredded waste plastic on hot aggregates, the strength and hence the longevity of the roads improved, thereby reducing their life cycle costs. But before we discuss the available models of plastic waste collection, the correct quantity and process for using it in hot mix plants, let us first understand the advantages and the limitations of bitumen when it comes to road construction, and how adding waste plastic mitigates its restrictions. Bituminous roads are more economical when compared to concrete roads based on initial construction cost. For example, the average cost per kilometer for a 3.75 meter wide standard single lane rural road using bitumen is Rs 45 lakhs per kilometer, while a concrete road costs more than Rs 60 lakhs per kilometer. Bitumen-based roads take less time to build because bitumen dries faster. It is a recyclable material and can be used many times by melting it. Bitumen roads are easy to repair even in small segments. They can also be relaid over the old layer. Bitumen roads provide better traction and skid resistance for vehicles because of its bituminous or viscous property. By virtue of this, driving on them is safer. Bitumen also absorbs dust particles. They are jointless, hence they provide a smooth ride. But with all its advantages, there are some drawbacks. Let us see what happens if water stagnates and penetrates between stone and bitumen. Because of inherent characteristics, the stone gets wet very easily, but not the bitumen. This loosens the strength of bond between bitumen and stone, which was holding all stones together. It peels off the bitumen from the surface of the stones, and thereby the stones slowly come out. Once the joints come out, potholes start forming on the road. So stagnation of water on it adversely affects the road. Another disadvantage is the harmful greenhouse gases bitumen emits when melted. This pollutes the environment and directly or indirectly affects our health in an adverse manner. With all its advantages and disadvantages, bitumen still remains a better option for construction of roads today. But it has always been a dream for stakeholders of road construction to increase the life of a road at a lesser cost, and also to determine if one can reduce the release of methane and other greenhouse gases by reducing the quantity of bitumen in construction of roads.
If you use instead of stone, plastic coated stone, the strength increases to 2,500 kilos. The stone and the bitumen mix has got a test called Marshall stability test. This test, normally it is supposed to withstand a load of 1000 kg. If it withstand, it can be used for road laying. But if you use on the same condition, if you use instead of stone, plastic coated stone, the strength increases to 2,500 kilos. That means plastic coated stone, used stone improves the quality of the road by preventing pothole formation, increases the strength of the road by increasing compacting characteristics. More than that, the amount of plastic which you use, to that extent we can reduce the bitumen consumption too.
Because of its characteristics, plastic in molten condition works more as a binder, something like araldite or fevicol. Actually, when a thin layer of plastic covers the aggregates, the bonding in the hot mix plants mostly takes place between bitumen and plastic, which has a higher bonding strength than bonding between aggregate and bitumen. Hence, roads which are made out of mixing plastic could withstand more load and could last long, even if water stagnates on it. As the recommended quantity of waste plastic is 6 to 8% of bitumen, one needs to heat and melt 6 to 8% less of bitumen, and this means substantial reduction in release of methane and other greenhouse gases in the environment due to heating of bitumen. India is one of the largest users of plastics, and thus it also has huge quantity of plastic waste. Because of the non-biodegradable nature of plastic, once it is discarded as waste, it remains intact in dump yards or in the soil, adversely affecting the environment and human health. It chokes sewage and stagnates water, which in turn creates havoc on the drainage system. Plastic, if left in the soil, also adversely affects soil productivity. Performance of road surface depends on following qualities of aggregates used in construction of roads: moisture absorption, soundness, aggregate crushing voids, Los Angeles abrasion, aggregate impact value. It has been observed as the percentage of plastic increases from 0% to 6% in PCA, plastic coated aggregates, by weight of bitumen, all the parameters tend to improve remarkably. Now, the advantages of mixing plastic have been well established, but the challenge has been to ensure supply of waste plastic near road construction locations and to train all involved in construction of plastic roads to use the correct process and quantity of bitumen and plastic. Though many sources of supply of waste plastic have emerged, but till now, two institutionalized sources of procurement of shredded plastic waste are recognized by the NRRDA. The first one is from municipal dump yards. As per statistics, almost 7 to 8% of municipal waste is plastic. As construction of rural roads with waste plastic is going up, some states, in collaboration with municipal authorities, have started systematically collecting, segregating, washing and shredding plastic. The municipal corporations are also adding to their earnings by selling shredded plastic.
This town on daily basis, 3,000 kilogram of waste has been generated, and we collected from the households and from the public places. Out of 3,000 kilogram of waste, 450 kilograms are recyclables. Out of that 450 recyclables, we got 50 kilograms of plastics. Those plastics we are washing and dried, and then we shredded using the shredded plastic machine. Thus, plastic has been sold to the contractors for laying of plastic roads.
The second model for making available regular supply of shredded plastic waste for using it in road construction is through women self-help groups. SHGs have developed a business model for collection of waste plastics from households. These are sold after cleaning and shredding to government and private road contractors. Various state governments like Tamil Nadu are also promoting women SHGs and are standardizing prices of shredded waste plastic.
போதிலட்சுமி, நான் வந்து ஒரு சமூக ஆர்வலர்னு சொல்லலாம். இப்போ இந்த மகளிர் குழுக்களில் எப்படி ஆரம்பிக்கணும்னு என் மனசில் தோணுச்சு அப்படின்னு சொன்னால், ஒரு தடவை சர்டிஃபிகேட்டை வந்து ஒரு பையன் கீழே போட்டு போயிட்டான். நாங்கள் வந்து போயிட்டு இருந்தோம்.
These models of procuring of waste plastic have ensured easy availability of shredded waste plastic for road construction. Utmost care has to be taken at the segregation sites of SHGs and municipal dump yards to make sure which kind of plastic has to be used and which has to be discarded. IRC guidelines has listed out the kind of plastic which can be used. Low density polyethylene LDPE, high density polyethylene or HDPE, polyethylene tetrafilate or PET, polyurethanes or PU, and the size of shredded plastic should be a maximum of 2.36 mm in length and 2.00 mm in width. IRC guideline has put PVC and black plastic in the list which should not be used for constructing roads. The IRC guideline strongly recommends that all plastic waste that has been recommended, in no case should it be heated at more than 180 degrees Celsius, as this results in the release of harmful gases and plastic would prematurely degrade. One has to have a basic understanding of the hot mix technique and process to appreciate how simple it is to add waste plastic in the same hot mix plant with minimum technical deviation. Let's watch. The standard process of constructing road through hot mix technology is to heat aggregates to 160 to 170 degrees in first heating chamber of the hot mix plant. Simultaneously, bitumen is also melted and heated to 150 to 165 degrees. This temperature is recommended for VG30 grade of bitumen, which is extensively used in rural road construction. Care is taken to ensure that temperature difference is 14 degrees between hot aggregate and hot bitumen for the best results. The hot aggregates and bitumen are mixed at 150 to 165 degrees in the chamber. It is immediately transported through dumper to road laying site to be laid at a minimum of 140 degrees by fully automatic machines. Once the machine spreads it evenly on the roads, it is immediately rolled at a minimum of 90 degrees temperature by a 8-ton or a 12-ton road roller. Well, if one lays the road this way, utilizing the right grade of aggregate and bitumen maintaining temperature as recommended by fully automatic plant and machine, the road will definitely work for 5 years without any problem. Now, in the same hot mix plant, 6 to 8% of shredded waste plastic is poured on hot aggregates in 2/3 portion of chamber to add it to aggregate, which is heated to 160 to 170 degrees in the first 1/3 of hot mix heating chamber. The plastic gets into a molten state and sticks to aggregates to create a thin layer of plastic around it. Both plastic and bitumen are organic in nature. They have a diffusion characteristic too, and hence they mix very well and adhere to the surface of the stone effectively. This makes the road last 6 to 7 years. If workers and technicians at the hot mix plant take care of the following 3 common mistakes and adhere to what has been recommended by the IRC guidelines, the strength of the roads goes up considerably. Maintaining recommended temperatures at all levels, appropriate quantity of plastic evenly spread out on hot aggregate, putting waste plastic on hot aggregates at appropriate temperature and not putting it on a conveyor belt. It is also recommended to test the quality and quantity of materials used to ensure durability. Now, scientists and engineers also recommend 2 compulsory tests to check if the entire process as given in the IRC guideline has been followed. Now, these tests are stripping test. In this test, a small chunk of bituminous plastic road surface is collected and is immersed in water heated at 40 degrees Celsius. Care has to be taken to collect samples only from the layer in which plastic has been mixed for construction of road. It is then left in the water for 24 hours to 72 hours. After the time is over, the sample is taken out of the water and observed for the peeling of the bitumen layer from the aggregate. If the recommended quantity of plastic is mixed and the temperature at all stages of hot mix process is maintained, the bond between bitumen and aggregate does not strip easily. But if the plastic is not mixed correctly, the layer will strip off and peel away. Extraction test. In this test, a small sample of constructed road is taken from the layer which is made out of waste plastic. It is weighed and then put in a separator with a solvent called dichloroethylene. As the separator stirs it, the bitumen gets dissolved in dichloroethylene and comes out of the separator. Now weigh the leftover aggregate, which is actually the plastic coated aggregate. As plastic does not get dissolved in dichloroethylene, the difference in weight taken before putting it in a separator and the weight of aggregate after bitumen is flushed out will tell the quantity of bitumen used in the sample. Now put the aggregate in a beaker and reflux it in another solvent called Decalin at 80 degrees for half an hour. The plastic coat over aggregate gets removed as plastic gets dissolved in Decalin in this process. Take the aggregate out and weigh the aggregate again. Difference between weight of aggregate before it was refluxed with Decalin and after it was refluxed would give quantity of plastic used in the sample. So with these simple tests, you can find out if plastic has been used or not, and if it has been used, what is the percentage of plastic in the sample in respect to bitumen. Now if all the processes suggested in the IRC guidelines are adhered to and the quality is controlled at all steps, rural India will have sustainable, cost-effective, environment-friendly and durable all-weather roads.